So I can only see 98. By the way, we have 122 students. So for the rest who may already join, let me see. We have 106 is joining. So you please go to the chat column there and click the attend and submit vote. This is part of the. This is how I'm going to take your attendance. Right. Some lecturers may take it from your participants list, but I prefer this because this one then automatically recorded your.
Not only here, but also in neighboring markets. Sale yesterday, but local products like peaches, grapes, apricots, and watermelons were in ample supply. And the prices stable. On Saturday,
Hey, sorry, can you hear?
academic convention inspection was conducted in markets across the city, including this
Okay,
one.
okay, sorry, I accidentally pressed the mute button.
Imported seafood.
Okay, so welcome to UEMB 3133 Mechanics of Machines. So I just repeat what I said just now. So some of you have joined this meeting or these lectures. Please go to the chat column and go to the top of the chat there. So you will find attendance record there. So you just have to click the attend and submit the vote. So this will automatically recorded your attendance into my OneDrive. So it's easy for me to manage. Some lecturers may opt for downloading your participant list from the participants, but I didn't prefer that one because that one for me that will record when you come in and when you go out. I just want a direct record only. So you just click attend and submit. Okay, so today we have lectures from 10 to 12, but maybe I want to highlight here that we will not going to do the full 2 hours lectures here, right? Because it could be quite, I'm not sure, because there are a lot of people feedback that when we have long hours on the online meeting, then it's quite tiring. But last Saturday only, last 2 weeks Saturday only, I have a online meeting from 9 a.m. to 6 p.m. In between only have half hour for lunch. Okay, so hopefully you have to adapt to this. We call it a new normal. So this is how we are living now. Hopefully this kind of living style will end soon. Okay. If you have anything, actually, you can also raise your hand. I think there's a function that you can raise your hand, and then you can ask questions. So today mainly I will go into OBE slides. The way I already shared in the lecture channel there, and also introductions to the course. Okay. So, and also myself, some of you may already know me, some of you don't know me. So this course will be conducted by two persons. So myself and also Prof. Andy. Prof. Andy will take care of tutorial. Okay, so I will take care of the lectures and practicals. So I will zoom in the things later. So now I would like to start with my with the introductions. Okay. Maybe I share my screen. So you'll see that my face will face down to the table because I'm using a tablet, so it's facing on the table. So I will not be always facing the cameras. Okay. So as part of the proof, so I will start the recording now. Okay. Okay, so we will look at the this one. Let me see. Yeah, I think you can see my screen now, right? So we are in the UEME 3133 Mechanics of Machine. So my name is Kim Yong Jin. You can call me Dr. King. Okay. My contact details. So you might be around Sungai Long, so there could be a chance that you can come to my office to meet me at KB level 8 FE62 Zone 2. Right. So and also my email is kingyj@utah.edu.my. I think because now we are using the Microsoft Team, it will be much more convenient that you just go to the chat function there and send any questions or anything you want to ask or discuss. You can just put into the chat directly, or we always call it PM me. You can just PM me, okay, instead of sending me email, because my email is quite congested. Also, sometimes I will miss your message. It's better that you send your message to the Microsoft Team. Okay. So consultation hours is every Tuesday and Thursday. So how are we going to do this consultation hours? Is basically I will be in the standby mode on the Microsoft Team from 10 a.m. to 12 p.m. on every Tuesday and Thursday. Right, so it means hopefully you will get a more quick response during this 4 hours time. But you can always send me your questions or your if you want to discuss with me anything. You can send me a message anytime. Right, I will try my best to reply you as soon as possible. Sorry. Okay. I switch off the slide first. I will move to the OBE slide, right? Because I'm the first. I think I'm one of the first or second lecturers who start this trimester. Because now it's only 10 a.m. on the first day of the May trimester. We still call this May trimester, even though we start from June. So I would like to switch my slides to OBE slides. Let me check. Okay, so we are now in OBE slides here. So we zoom in. So this is part of the our OBE implementation. So anyhow, I think every lecture will still brief you the same thing. So this is part of the awareness that we have to create for the to the student. So for your information, all our program, especially engineering program, is accredited under this what we call EAC, Engineering Accreditation Council. So the EAC is adopting this OBE method on teaching and learning. So that's why student is considered one of our stakeholder in this OBE system. So that's why we will brief you this OBE. So this slide is prepared from university-wide. So it's OBE briefing for students. Right? So what is OBE? Okay. OBE is an approach that focuses on the attainment of learning outcome. Right? So that's why I call it as an outcome-based education. So it focuses on what is essential for students to be able to do successfully at the end of their learning experience. So that's why here you will see every of your course have a course outcome. So your assessment, for example, your midterm test, your assignment, your practical, your In this sem, it will be your final assessment. Will all test on your course outcome, based on your course outcome. So what are the difference between the traditionals and the OBE approach? So this is one of the difference there. So in traditional education system, where I experience, not you, where I experience is the lectures will actually focus on what to be taught. So and what teaching method should be used. So, but on OBE is we will more focus on what student will know and able to do after the lectures. So means the focus is different. So under teaching means that in traditional method, we will actually transmit the knowledge, ideas, and value to the students, right? So basically, a lot of us, including myself, I'm still in this more toward traditionals because I train under this system. We are trying to learn or practice this. So under OBE, we try to devise the teaching and learning activity that requires students demonstrate how well they have achieved the learning outcome. Right? So I will be happy that if you can also be more interactive, you can participate or you can ask questions in my lectures. Right? Because I always believe that we still learn, including myself. When I teach mechanics of machine, then I still learning. Right? So we will learn more and more detail and details onto the subject matter. So you may ask some questions that I may not be able to answer. So then we can discuss. Okay, so you can still see my screens, Okay, so under assessment, traditional method, we assess how well students have received the knowledge. So, but on outcome-based education, we assess how well the student have achieved the learning outcome. So in short, OBE approach is a student-centered, while traditional approach is a teacher-centered. Right? So what are the impact of transformation for teacher-centered to student-centered? So this is the things here. So teacher-centered will have course objective, and then there is no mapping to the learning outcome. So student has to be independent learning, right? And then the student independent learning is not calculated, right? So means under teacher-centered, we will not bother how much time you have to spend on your study. So you have to work very hard, right? And then contact hours. So this is reflected to the credit hours or credit values. So under OBE, we are actually now at the student-centered. So we have this learning outcome where all the students should be achieved. Okay, and then mapping of the learning outcome. Okay, and then means which other topic is matched to which learning outcome. Right. So student independent learning time is calculated. Right. So later I will show you the syllabus. So where is it? And then total self-learning times will actually reflect the credit hours for your course. So this one I think I will just skip. You can read because it's just a definition of the credit hours. Right? How does OBE work? So basically OBE answer these 4 questions here. What do you want the student to learn? Why do you want them to learn? How can you best help students to learn? And how will you know what they have learned? Okay. So how we define this, how we answer the 4 questions there. So basically we are actually doing all this, defining course outcome, right? Providing learning activities, and also assessing the students, right? So this is how we're trying to use utilizing the OBE method to improve the learning process. So it means when we have a learning outcome, then the learning will be more focused. So you know what you have to focus and learn in this course. And then designing now means down means we have a clear definitions of the curriculum design with clear outcome that students are to achieve by the end of the program. So that's why each of our course will link to the what we call it a program outcome. Right? And then high expectation. So teachers can establish challenging standards of performance in order to encourage students to engage deeply in what they learn. So you'll find out that your course in the first year compared to your third year or final years, your questions become more and more challenging. So in year 3 and year 4, you always have to do evaluation, design, and so on. And then expanded opportunities. Yeah. So that's how I already mentioned why we have to use this OBE, because this is a requirement from qualification bodies and professional bodies. So such as MQA, MOHE. So MQA is Malaysia, this one, Malaysian Qualification Agency. MOHE is Ministry of Higher Education. BEM is Board of Engineers, and the EAC is Engineering Accreditation Councils Malaysia. So these are the qualification body and professional body that actually set this requirement. So this is how we work, OBE for under UTA. So UTA have a vision, missions, and then every program will have a program educational objective, and then we have program outcome. Right? And then these are all your course outcome. So this is UTA vision and mission. You can always find it in the website, our UTA website. So one of the reasons why I have to brief you this is because on and off EAC will come to do accreditation. So they will ask you, they may actually select some student to ask things like this. So that's why at least you know the concept. You may not know exactly what is the mission of UTA 1, 2, 3, 4, but you know that they are mission, UTA mission, okay, at least. So this is what I mentioned just now, PO and CO. CO is achieved after every course. PO you have to achieve by the time you graduated. Okay? So if you are now year 3, means next year, year 4, you should achieve all the program outcome. And then program educational objective, you will only be achieved within 3 to 5 years after your graduation. So in future, when you graduated, when UTA send you some survey form, try to do it. We have to compile the data and send to the EAC for accreditation purpose as well. So again, every program has 3 PEO. So you can refer to your own program. This is just an example. And then for engineering course, all the program will have 12 program outcome. Right? So more slightly is similar. Right? So first one is always engineering knowledge. And then we have lifelong learning, and also project management and finance. That's why you still have to take the course project management and some finance related course, because in future you might be one of the boss. For example, you may set up a consultancy firm, so you still have to know project management, finance, accounting, and so on. So this is a mapping. So every program outcome will map to the program educational objective. So all the CO, course outcome. So course outcome will also map to the program outcome. Later we will look at the one. Yes. Anyone? No? So this is when we have all the assessment. For example, just now I mentioned we will assess you through practical, midterm, and then final exam or assignment. So we also have to do this mapping. Right? So nowadays, teachers in school and lecturers in university are quite busy on mapping all this. Then we will have to calculate all your achievement, okay? Your class achievement, what is the course outcome achievement. And then this is individual program outcome achievement. So I'm not sure how many of you ever asked from your academic advisor. You can ask from your academic advisor to look at your program achievement. So your academic advisor has the access to your program outcome achievement. Right? So when you have AA meeting, actually you can request to look at it. So this is an example. A PO, you already achieved 75. Some of the PO is 0 because maybe the student is only year 2. Those subjects have not mapped to PO 4, right? Or program outcome 4. Right? So it may go to year 3 or year 4, only there's a subject linked to this program outcome 4, then only you can obtain the number here. Okay, so this is the end of the OBE briefing. Okay, so then we move to instead of this, then I would like to move to our syllabus. Can you see with the syllabus? Anyone can respond to me? Can you see the syllabus? Yes, okay. So this is mechanics of machine. So we have in total, there is a prerequisite here, means you must pass, not just take the dynamics, you must pass the dynamics. So everyone who can, who actually can register this subject means you've already passed the dynamics, right? So we have 6 course outcome here. First one is to calculate the inertia of rotating system, right? So you should expect that I will ask you these questions. I will ask you to calculate the mass moment of inertia for any geometries. Okay. Sure have this question one. Okay. And then course outcome 2, construct the kinematic and dynamic equation for force analysis of linkages mechanism, linkage mechanism. So I think you can still see my video. So I have tried to 3D print some something here. So maybe I show you one of it. So when we say linkage, it's like this, right? So this is we call it crank slider, right? Hopefully I can turn it, right? So this one you can find this in a lot of application, right? This is a crank slider, so means you have this is a crank. Right? My joint there is not good, So we have maybe I turn it down like that. So this is a crank, and then we have a connecting rod, and this is the we call it base because normally if this part is the part not moving, we'll call it a base. Oh, then I better turn off my, because I see that you can't see it. But now can you see it better? Can you see better? Yeah. Okay. So this is a crank slider. I have to improve my joint here. Just give me a second. Let me see. Okay. So the slider here, we call it the fixed base. So when we turn this, so can you see it moving? Okay. So maybe I hold it somewhere here. Okay, I hold it somewhere here. So this is a crank. Okay. So this part we will call it fixed base. Okay. And then this is a connecting rod. Okay. So this mechanism is actually very useful, and it has been used in many mechanisms. So one of it is your engine. Okay. This is the engine. Maybe slightly further. So again, when you turn, that is how it moves. Okay. So again, this connection here from this red dot here to the center of this rotation, that is a crank length. Right. So this is a connecting rod. But now the difference here is I don't have the slot slider here. Instead of having that, then I have a cylinder movement. So that's why this mechanism is also called a 4-bar slider. Just now this one is called 4-bar slider because this is called 1 bar, 2 bar. This is a 3, and then the case itself, the base itself is number 4. Is the 4-1, number 4. So for this one is 3 bar. Just now the blue color one I showed. Okay. Because the reason here is this connecting point, there is no mesh. We assume there is no mesh. Okay. So that's why you only have one, which is the crank, and then the base is the number 2, and then we have connecting number 3. So we only have 3 bar. Right. So there is so if you put everything together, you may get this kind of thing. You put more complicated one, then you can have this radial engine. But now it's very hard to see this engine anymore. Okay? So we will touch on all these things again in coming lectures. Okay? So now we move back to my slides here. Okay? My syllabus here. Okay, so that is a linkage. So we have to calculate the inertia of every link, and then calculating the acceleration, the position, and the velocity of the linkage. And then the third one is evaluate the static and dynamic balance in rotating mechanism. So it means when things start to rotate, if there is just a small unbalance, you will create a huge impact to the system. Okay, so and then the course outcome number 4 is the dynamic force analysis and moment of multi-cylinders reciprocating engine. Okay, so we will start with just now a simple one cylinders, and then we will further go into multi-cylinders. Okay, so we will look at the 2 cylinders, 3 cylinders, 4 cylinders, and more. Okay. So the number 5 is design and analysis of gear train system. This one should not be too difficult for you because you have been going through this under your mechanical system design and mechanical engineering design, MED right, course. So it's just kind of related to the things that you learn there. And then the last one, course outcome number 6, is to conduct experiment and analysis and interpret the data and presenting the result in the written repertory report. So for this part, confirm that we will not have this. Right? Sad to say that because of the recent announcement by the Ministry of Higher Education, so they only allowed the year 1 and year 4 students to go back to the campus to do the physically. So our course is listed as a year 3, and this skill is not compulsory for mechanical engineers. So that's why we will not have a physical experiment. right, conducted in the campus for this trimester. But for anyone who wish to look at or to try the experiment after this, so you can still find me, and after maybe when there is allowed to go back, so you can look for me, then I can show you again, right? So for this trimester, our focus is we're only on the analysis, interpret data, and presenting result of the repertory in the repertory report. So it means that I will actually show you some videos, how the machine is working, and then I will also share you the data. So then from there you make your practical report. Okay, so it's clear. So for UEME 3133 mechanics of machine, you don't have to come back to Utah campus. We'll do everything online. Okay. So that's how in the OBE briefing, we have a course outcome map to program outcome. So that's why you see the mechanics of machine only contribute to the 4 program outcome in your program. So this is same for mechanical or even mechatronic, because we have 2 program students here. So just now we also mentioned that the credit hours is calculated from this total learning hours. Okay. So that's why we have a lectures hour, tutorial hours, and then independent learning hours, right? And then this is a total self-learning hours. So every topic will assign how many hours you have to spend on, okay? And then total up, you are basically getting 120 hours. Means that theoretically, you should spend 120 hours for this course, right, during this semester. So you can also make your timetables for those who are who used to make your own timetable. Then actually you can try to turn on or open up all these syllabus, and then you can work based on these hours that we assign. And then you can make your own timetable. Right? It will be very useful for you to plan your time. Okay, so for the reference books, right? So I turn off my screen first. Right? So this is the actually now when you see the thing is in the right orientation or not, because I look my camera is upside down. It's a flip between left and right. Or it's right, so you see the right thing. Because I think my one is a mirror. Okay, so we'll use this book by Norton. It's a very famous books under this kinematics and dynamics. So if this is actually SI unit, right? So if you find a US version, right, that is on your own capacity, you should be able to find online one. So they also call it a machine design, if I'm not mistaken. So because the US version, they put a different title, okay, but the content is more or less the same. They call it machine design, right? Yeah. Okay. Thank you for snapping the photos. So you look at the right one. Okay. So okay. So that's why you over here we take this as a main reference. Okay. Design of machinery. So this is another, if not mistaken, this is a US version. So if you notice that engineering books, a lot of it, they will have a US version and international version or Southeast Asia version, because the price is totally different. Okay. The Southeast Asia version will be much cheaper. Okay. Okay, so this is the rest of it is just the topics, and also we have 4 experiments here. So I will make a table on how are we going to distribute these 4 experiments, because every one of you only have to do 2 out of 4. Okay. So, but the number 4 is compulsory. Even though we will not come back to the campus to do the physical practicals, but actually experiment number 4 you can do at home. Okay. So I may require you to do this at home. Right? So there are things that you can do. Right? So because mass moment of inertia, you can calculate or you can measure the mass moment of inertia from the oscillating time. So we can relate this mass moment of inertia to the oscillating period or the subject in the vibrations, right? So means that, for example, sorry that I keep turn on and off my cameras. Okay. So for example, we have these objects. So it looks like this. Right? This one actually I'm doing it for a 4-bar linkage. So I will show you when we come to the subject. So for example, I have geometry like this. Now I want to know what is, or I want to measure, not calculate only. I want to measure its mass moment of inertia. So what I can do is I can displace these objects at a small angle, and then I let it oscillating. Okay, I calculating is oscillating period. Based on the oscillating period, then I can calculate its mass moment of inertia. So maybe later when we do this experiment, you can find something in your house that the geometry shouldn't be too complicated, because I want you to compare to the theoretical value. Right? So it's better like this one. I only have 2 cylinders and 1 rod, so then I can do it. I can do the calculation easier. Right? So you may find something square, so that then you measure and then you can compare to your theoretical calculation value. So at least you have some hands-on experience on this, the topic number 4 here, mass moment of inertia. Okay. Okay, then I move back to how long already? About 44 minutes already. So now I come back to here. So for this course, the synopsis here is the subjects provide the fundamental of mechanics of machine, including kinetics and kinematics of mechanism. So when we say kinetic and kinematic, normally we will start from the kinematic first. We calculated the position, we do the position, velocity, and acceleration analysis first. Then we will do the kinetic calculation, which involves the force, the mass, and so on. Right? Similarly, for example, if you are trying to design a car, so normally you will set what is the car limit you are targeted, the car speed limit you targeted, the overall weight you targeted. So you have a framework first. Then only we will zoom into how to make the things happen. So this one just now already highlighted the 6 the 6 course outcome. Okay, so this is maybe it's very important for you to know. Again, because the government or the ministry already announced that there should be online teaching and learning until end of the year, 31st December. So that's why for Utah, majority is not all, because some program they are required to come back and do a physical exam as well. For example, medical program, they have no choice. They have to come back to the campus and sit for their exam, because this is under their professional body requirement. So or else then they have to postpone their study. So for engineering, then EAC allowed online tests and so on. So that's why Utah-wise, we majority we change our final examination to the final assessment here. Sorry. final assessment. So, but the total, the weightage has been reduced to 40%. Okay. The previous one, final exam, is always 60%, but now it reduced to 40%. But do remember that all your engineering courses, you still have to, is still subjected to the conditional pass. Means you must pass your final assessment. Mean over here you have to get 40% of this 40%. Then it should be 16 over 40. Right? You must achieve 16 over 40. Then only you are eligible to pass the course. So remember, you must do your final assessment properly. Right? So instruction or guideline from the university or from the faculty. So your final assessment now is targeted to be shorter. Instead of what you experienced last sem, you may get the question and then you submit in 2 days or even 4 days or some even 1 week time. So now the final assessment will be more standardized. If not mistaken, your final assessment, you will be given maybe 4 hours to complete instead of 2 days. All right. So now it's a time-based, they call it. Time-based means the lecturers will give you a time frame, right? So in general, it's 4 hours. So then, because with this, then the exam department will be able to arrange your exam timetable. Not like last sem, because everything is too dynamic. Everything is changing every day. So some of you may get 2 final assessment at the same time and then submit maybe 1 day different. Right? So this round we will go for time-based, so hopefully we will have a better timetable for you. So you don't have 2 final assessment at one time. Right? So the rest of 60% will be your coursework marks. So midterm test 15%, assignment 30%, okay? And then practical repertory 15%. So add up everything, it will become 100%. All right. So we have in total, if not mistaken, 7 topics here. So we will start with the dynamics fundamental. So you have to learn about what is dynamic models, mass moment and also central gravity, mass moment of inertia, parallel axis theorem, radius of gyration, central precaution, and energy methods. So second one is a kinematics analysis of mechanism. So as I show you just now, there is one of it, the three bar sliders. So we will learn about 3 bar sliders, 4 bar linkage and 4 bar slider linkage. Right? So from there we'll learn about how to calculate is position, velocity, and accelerations, right? Of all these linkages. Then dynamic force analysis is an extension from the kinematics one, means we go into the kinetic section. So from here then we will be able to calculate is force, right? Or the torque, and shaking force. So from there then we also introduce you the flywheels. Okay? Flywheels is a component actually, especially for boy. If you have a toys car, you already use this flywheel since maybe you are 3 years old, right? So if you still remember that I believe majority of you will have a toys car where you try to push it few times at the same place, and then when you release, it will move by itself. So that car, if you open up, you'll find a flywheel inside. You may see it before, but you may not know its name is called flywheel, right? Because it just looks like a multiple washer stacked together. Right? So that is actually flywheel. It's an energy storage mechanism. So when we go to topic 4, we'll do balancing, because that's how in the previous topic, if you look at that, we talk about shaking force. So balancing can help to reduce this shaking force and any unbalance in the system. So our car engines now have a very good balancing. Your airplane turbine actually do this balancing in very details, and so that when the airplane engine flies, you will look. If you look at the jet engine or the turbine, it don't shake that much, because they've done a very tedious balancing on the turbine before it's being commissioned and used. Okay, then we'll move on to the engine dynamics. So we'll start from with the one cylinders first. There's a model I showed you just now. So there is a slider crank mechanism as well. So from there, gas force. In our case, we will not study about gas force. We actually just assume the gas force and the gas torque. Right? No, we actually assume the gas pressure, right? The combustion pressure. Then from there, we can find out how much force and how much torque actually deliver to the crank, right? Right? If you're interested on how much pressure the combustion can give you, I think then you have to take the internal combustion engine. So it will teach you over there, right? So this part will be will serve as the introduction to the internal combustion engine, right? So multi-cylinders engines, right? So this is very common. You see in your every car, right? Cars start from one cylinder and then two cylinder, and then they go more and more until, if you see at the Ferraris and so on, they go for V12. If you look at the trucks, then you see the trucks, they may be V18. If you go to offshore platform, then you may see V24. All right, mean one side 12 cylinders. So they have two sides put in the V shape, then they call it V24. So that is for power generation. They're also utilizing this internal combustion engine, right? So we will look at it. So as I mentioned, initially from very little cylinders to many cylinders, but now because of the emission issue, now all the engine manufacturers reduce the engine, right? So how to make them still working? So they put in the turbocharge, the hybrid system, so that they still get the same power output. Okay. So from here we'll look at the inline engine. Okay. This is very common in the car. So if not mistaken, any car below 200,000 normally is an inline engine. Okay. So then we'll look at the V engine configuration, and also some of the other multi-cylinder engine, as I showed you just now, the radial engine, this one, okay, radial engines, that actually being invented since in the World War, right? So the last one is a gear train analysis, fundamental law of gearing and gear types for motion transmission. So motion analysis of a simple and compound gear trains. So transmission and motion analysis for epicyclic gear and transmission efficiency. So if you notice just now, one of our experiments is on the epicyclic gear train. So again, this is our reference, same as the one in the syllabus. So another thing to highlight to all of you is that for this semester, the attendance back to become very important. So that's why just now the form, you have to click attend and submit your vote. Okay. So I will paste the attendance list later in this in the chat. Okay. So you can always talk to me if your attendance is not correct. So you must make sure you check your attendance by week 12, or better is before week 12, maybe week 11 or early week 12. You check it, and then you have to confirm that the attendance is correct. So because anyone who has less than 80% of attendance will be barred from your final assessment. Right? Now no final exam, so we call it final assessment. So if your attendance is less than 80%, you will be barred from taking the final assessment and you will fail the subjects. So make sure, so that's why you have to make sure you log into the Microsoft team and follow the online class. So this including the lecture, tutorial, and practical. Right? So attendance will be counted during the online classes. So for myself, I will not unbar any student from the bar list because I already give the option to you that before week 12, you should see me. Because on week 12, I shall not enter any or modify any attendance from there until the system is locked. Okay, I think we have been going through about 1 hour. Let me turn off first. So any questions from you guys? So far, no. Any questions? And submit. You can submit the word twice if you don't confident. Your attendance is being recorded. So if not mistaken, the system is clever enough to just recording count once instead of counting two. You can submit 2 or 3 times, right? Because for me, it's also easy to filter out later because they will give me a Excel format, right? So I can double check, right? When will you release the assignment? The assignment is expected to be released maybe by week end of week 2 or early week 3, right? Because we have to go through the moderation process, right? So your midterm, your assignment, I have to send to the moderator to check, and then only I can release to you. All right. So any more questions? Someone asked 4 hours. Yes, the final assessment, as we know, is 4 hours, unless there is any changes after this. Don't too worry. We will, as a lecturer, we will plan something that you can finish in 3 hours instead of 4 hours, even though we give you 4 hours. So how about midterm? Will it be like FA or MCQ? Definitely for me, not MCQ. It will be more like FA. Okay, it's also a time based. Maybe as current planning is, we will do it on the week 8 Monday lecture time. Similar to today lecture time, 2 hours. Right? So I will post the questions, and then you have to solve within 2 hours. But then the one you don't need to type, right? We try to minimize that. Midterm is week 8 Monday 10 a.m. Correct? Unless there is any changes, only I will inform you. If not, this is the current plan. So it's more like a FA, but you have to do it in 2 hours. So you have to get ready your cameras to scan your answers and then submit. Right? 2 hours, maybe I only plan for the question is about 40 minutes. Right? 40 to 45 minutes, then you can use 2 hours to solve it. Right? So any more questions? Or anyone miss to go back to the campus? For the time being, I think student is still not allowed to go back unless you have a special request. For example, you left your books there, you have something in the lab you didn't take back, you want to go back and take. So that is possible. You can contact the LMSA department. You go to LMSA website, there is a pre-registration link there, so you can register and go back to take your things if you left anything in the campus. Okay, so for year 2 and year 3, confirm cannot go back unless you are doing the IDP. Any one of you doing IDP, then you have to go back after from 3rd August onward. Okay. For the assignment, I cannot answer you yet. Design based or question based, right? But normally it's design based, right? Until the moderation, I pass the moderation first, so then I will let you know. IDP part 1. This one, even though not related to our course, but IDP part 1, if not mistaken, you don't have to go back. Only IDP part 2, right? Means they need hands-on, right? Only have to go back. So anyone facing problem on internet access or computers or so on, if you know, or if, maybe everyone can join my lecture now, shouldn't have problems. So if you know any of your friends having this problem, they ask them to contact the head of department, right? For mechanical is Dr. Yo Wei Hong. For mechatronics is Dr. Kwan. They have to contact the HOD and look for a solution, right? Don't wait until the last minute. Now is week 1, week 2. I think you have to settle everything first, right? So I think from now you have to spend time to polish up your skill on scanning document. A lot of phone or apps now can use to scan document. You don't need a scanner, right? You just use your phone, but then you might have to find printers, right? Do you guys still want to continue, or we start our proper lectures on the Wednesday? Wednesday we have another class, right? Maybe I show you my timetable. Okay, so this is my timetable. So we still call it May trimester from 15 June to 20th of September. So you can forget about Skype, even though I still have the Skype. So because now we have Microsoft Teams, so you can always find me on the Microsoft Teams. So this is our today lectures. Then practical will be here. So practical, instead of 3 hours, maybe you will occupy the first half hours or first hours only. So I will explain the experiment to you, and then after that I will share to you the experimental data. So we have group 1 to 8 here. Okay. So my consultation hours, as I mentioned, you don't have to worry about this. You can just text me or message me anytime. So we have another lectures on Wednesday. So maybe we'll start our proper class on Wednesday. So I will also do a voice over slides. But my way of doing it is I will do the voice over, or I will share the voice over slide after my class, because I don't want to share before. Because when before, then no one want to come to my class. Okay, so my voice over will be after the class. Okay? So for example, this week I done maybe first lecture slide, then next end of the week or beginning of next week, then I'll post the voiceover one. Okay. So you know, if I post it, then no one come to my class. Also, I have troubles. Okay. As I always joke with the student, I say why I become a lecturer is because I like to talk. So I have to make sure you listen to my talk. And now it's a bit not that excited because I can't see you. Actually, faculty request can every student turn on camera, but we tested in the faculty that it requires a very good computer to support. For example, now I have 120 students. Everyone turn on the camera. I think some of your computers may have problems to handle the image. Okay, so yeah, that's why we will not share all the cameras. But in my meeting, professional body meetings, whenever you want to talk, it's better you show your face. If not, after when you come back next year, January, you come back, I don't know who is my student, right? So maybe suggestion, you can put your photo on your profile photo also. Just like if you can see my profile photo, is taken by a professional photographer. So it's a good photo. Okay. I saw some put our PM, Prime Minister photos. So how can I recognize you after this? Okay. Okay, I think for today, I stop here. Is it okay? So we will start our actual lectures from topic 1 and onward. But normally I won't do a full coverage. For example, 2 hours, I will not do full 2 hours, or 1 hour, maybe we do about 40 minutes. Then we should stop. Okay? I don't want you to be too tired or facing the PC too long. Okay? So see you on Wednesday. Thank you very much. So make sure you already take your attendance. Okay? Thank you. So you can leave the meeting now. Thank you.